What if I told you that there was once a time when you could walk from New York to Morocco without ever seeing an ocean? When massive reptiles, the size of school buses, roamed through forests that stretched unbroken across what we now call 6 different continents? This actually happened. And tonight, we're going to journey back 300 million years to discover the lost world of Pangea. In the next 3 hours, you'll discover how our planet once looked completely alien, how life survived in ways that seem impossible today, and how the very ground beneath your feet carries secrets from this ancient supercontinent. Scientists kept some of these discoveries hidden for decades, not because they were classified, but because they were so extraordinary that even the experts couldn't believe what the evidence was showing them. Before we begin this journey together, take a moment to like this video if you're ready to explore the impossible. Subscribe for more cosmic dreams, and comment below with your country and what time you're listening. Are you drifting off to sleep in Tokyo at midnight, or perhaps watching the sunset in California? Let's create a global community of dreamers, all traveling together through deep time. Tonight, prepare to witness a world where the familiar map of Earth becomes unrecognizable, where the climate defied everything we understand about weather patterns, and where creatures evolved in ways that challenge our very understanding of life itself. Close your eyes and imagine looking down at Earth from space. But this isn't the Earth you know, with its familiar blue marble, adorned with the recognizable shapes of North America, Africa, and Asia, scattered across vast oceans. No, this Earth looks utterly alien. Picture, if you will, a single massive landmass stretching from pole to pole, surrounded by one enormous ocean that makes our Pacific look like a small lake. This was Pangea, the supercontinent that existed between 335 and 175 million years ago. The very word Pangea means all earth in ancient Greek. And as you'll discover tonight, it was far more extraordinary than its simple name suggests. But here's where the story becomes impossible to ignore. When scientists first proposed that all our continents were once joined together, they were ridiculed, dismissed, and told their ideas were scientific fantasy. The evidence was right there, scattered across every continent on Earth, but it was so incredible that even brilliant minds couldn't accept it. Imagine standing on a beach in what we now call Brazil, picking up a smooth, rounded pebble. Now imagine walking northward, never encountering an ocean, through vast forests and across rolling plains, until you reach what we now call Scotland. There, on another beach, you find the exact same type of pebble, made from the exact same rock, formed in the exact same ancient river system. How could this be possible? The answer lies in understanding that our planet's surface isn't the solid, unchanging foundation we imagine it to be. The ground beneath your feet is floating, drifting across a molten sea at the speed your fingernails grow. Over millions of years, this gentle movement reshapes entire worlds. Tonight, we'll walk through forests where New York City now stands, swim in tropical seas where London now sits, and witness the birth of mountain ranges that no longer exist. We'll discover how the very air you're breathing was different then, how the night sky blazed with colors that would seem impossible today, and how life itself took forms that challenge everything we think we know about what's possible on our planet. But our journey begins with a mystery that puzzled scientists for over a century, a puzzle whose pieces were scattered across every continent on Earth, waiting for someone brave enough to see the impossible truth. In the early 1900s, a German meteorologist named Alfred Weising noticed something that would keep him awake at night for decades. He was staring at a world map, the same kind you might have hanging in your classroom or office, when he saw it. The edges of the continents fit together like pieces of a jigsaw puzzle. But this observation alone wasn't enough to keep scientists awake at night. What began to haunt them were the fossils. Imagine discovering the bones of a massive reptile called Leistrosaurus, a creature the size of a large pig with tusks like a walrus. You find these bones in South Africa. Then, impossibly, you find identical bones in Antarctica. Not similar bones, not related species, but exactly the same creature. How did a land animal that couldn't swim cross thousands of miles of ocean? Picture another discovery. Glossopteris, an ancient fern with leaves the size of dinner plates. Its fossils appear in Australia, then in South America, then in India, then in Antarctica, and finally in Africa. The same plant, growing in locations now separated by vast oceans and dramatically different climates. Antarctica, now a frozen wasteland, once hosted tropical forests. The rocks themselves told an even more impossible story. Geologists found identical mountain ranges, formed at exactly the same time, using exactly the same processes, in Scotland and the Appalachian Mountains of North America. Not similar mountains, but essentially the same mountain range, as if someone had taken a photograph and torn it in half. But perhaps the most haunting evidence came from the ice. Scientists discovered the scars of ancient glaciers, massive scratches gouged into bedrock in places that are now tropical. The Sahara Desert, one of the hottest places on Earth, showed clear evidence of being covered by a continental ice sheet. Meanwhile, coal deposits formed from tropical swamps were found buried beneath the Arctic ice. The evidence was overwhelming, impossible to ignore, and absolutely incomprehensible if the continents had always been where they are today. Something extraordinary had happened to our planet, something that required scientists to completely reimagine the very nature of Earth itself. But the most incredible part was yet to come. The evidence wasn't just telling them that the continents had moved. It was revealing exactly how they had moved, when they had moved, and what the world looked like during each stage of this incredible journey. As we drift deeper into our exploration of Pangea, imagine yourself as one of those early scientists, staring at evidence that defies everything you thought you knew about the world. Feel the excitement, the confusion, and the growing realization that our planet holds secrets far more incredible than anyone had ever dared to imagine. The mystery was no longer whether the continents had moved. The question was, what kind of world existed when they were all together? To understand Pangea, we must first witness its birth, a process so slow and inevitable that it unfolded like a meditation spanning hundreds of millions of years. Close your eyes and let your consciousness drift backward through deep time, far beyond human history, beyond the age of mammals, beyond even the first forests. 350 million years ago, our planet was in the midst of an elegant dance. Massive land masses, like sleeping giants, drifted across the surface of the Earth, carried by currents in the molten rock beneath. These weren't violent collisions, but gentle embraces that took millions of years to complete. Imagine watching from space as the ancient continents of Gondwana and Laurussia slowly approached each other. Gondwana, containing what would become South America, Africa, Antarctica, Australia, and India, was moving northward at the speed of a growing fingernail. Laurussia, holding future North America and Europe, drifted southward to meet it. Between them lay the Rheic Ocean, a body of water that made our Atlantic Ocean look modest. But this ocean was doomed. Year by year, century by century, millennium by millennium, it grew smaller as the continents approached each other like two lovers meeting after a long separation. The collision wasn't sudden or catastrophic. Instead, picture the gentlest possible embrace, spread across tens of millions of years. The ocean floor, nowhere to retreat, was slowly crushed between the approaching landmasses. The seafloor sediments, containing the remains of countless ancient sea creatures, were compressed and lifted, forming mountain ranges of impossible height. This is how the Appalachian Mountains were born, not as separate peaks rising from the ground, but as the crumpled edge of a closing ocean. The same process created the Caledonian Mountains of Scotland, the Anti-Atlas of Morocco, and the Ouachita Mountains of Arkansas and Oklahoma. All part of the same mountain system, formed by the same gentle but irresistible collision. As the final gap between the continents closed, something magical happened. Rivers that had flowed into the vanishing ocean suddenly found new paths. Climate patterns that had been stable for millions of years shifted dramatically. Ocean currents that had circulated around the globe for eons were suddenly blocked, redirected, or eliminated entirely. But the most profound change was something that would affect every living thing on the planet. The interior of this new supercontinent was further from any ocean than any place on Earth today. Imagine standing in what would become the center of Siberia, but knowing that you are over 1,000 miles from the nearest coast in any direction. The climate here would be unlike anything that exists on our planet today. The formation of Pangea wasn't just a geographical event. It was the creation of an entirely alien world, with weather patterns that seem impossible, ecosystems that challenge our understanding of life, and landscapes that exist nowhere on Earth today. As we continue our journey through this lost world, feel yourself settling into the rhythm of deep time, where changes that seem impossible become inevitable, and where the very ground beneath your feet tells stories of transformations beyond imagination. The supercontinent was complete, but its story was just beginning. Picture, if you can, standing in the very heart of Pangea, in what scientists call the continental interior. You're surrounded by land in every direction, but this isn't like being in the middle of any continent today. The nearest ocean is over 1,500 miles away in any direction you choose to walk. This is a place Earth has never seen before or since, a true landlocked heart of the world. Take a moment to acknowledge the incredible journey you're on tonight. Whether you're listening in Mumbai at sunrise, London at midnight, or Los Angeles as the evening settles in, you're part of a global community exploring the deepest mysteries of our planet together. The same wonder that's drawing you into this story connected those early scientists who first glimpsed the impossible truth of our drifting continents. The climate in this interior was unlike anything that exists on Earth today. Without nearby oceans to moderate temperature, the heart of Pangea experienced extremes that would seem alien to us. Imagine summers where temperatures regularly soared above 140 degrees Fahrenheit, hot enough to kill most life forms we know today. Then picture winters where the same locations plunged below freezing, creating a seasonal swing of over 160 degrees. But the most extraordinary aspect wasn't the temperature. It was the complete absence of rain for months, sometimes years at a time. Ocean-borne moisture simply couldn't penetrate the vast interior of the continent. Clouds would form over the distant coasts, drop their rain on the edges of Pangea, and leave the interior in permanent drought. This created something that has never existed since: true continental deserts. Not like the Sahara or Mojave, which are relatively close to oceans, but absolute wastelands stretching for thousands of miles. These were landscapes of red sandstone and wind-blown dunes, where the only sound for hundreds of miles might be the whisper of sand against rock. Yet life, in its infinite creativity, found ways to survive even here. Strange reptiles, unlike anything alive today, developed the ability to store water for months. Plants evolved waxy, impermeable skins and the ability to remain dormant for years, waiting for the rare rainstorms that might come once in a decade. The night sky above this alien landscape blazed with colors we can barely imagine. Without moisture in the air to create our familiar blue atmosphere, sunsets painted the sky in deep purples and oranges that lasted for hours. The stars appeared so bright and clear that they cast shadows on the ground, and the Milky Way stretched across the heavens like a river of light. But perhaps the most haunting aspect of the Pangean interior was the silence. Without forests to rustle in the wind, without rivers to babble over stones, without the vast chorus of life that fills even our most remote places today, the heart of Pangea existed in a silence so complete it would drive modern humans to madness. This wasn't a dead world, but it was a world that followed rules completely different from anything we know. It was a laboratory where life experimented with survival strategies that have never been needed since, where evolution explored possibilities that seem impossible to us today. As you drift deeper into sleep tonight, imagine yourself walking through these silent landscapes, feeling the dry wind against your skin, watching the alien sunsets paint the sky in impossible colors. This was our planet once, as real as the ground you're lying on now, as real as the air you're breathing. The story of Pangea is far from over. As we journey deeper into this lost world, we'll discover that the edges of this supercontinent held secrets even more extraordinary than its barren heart. While the interior of Pangea baked in its continental furnace, the coastlines told a completely different story. Here, where the vast Pangea Ocean lapped against the shores of the supercontinent, life exploded into forms of beauty and complexity that would seem like fantasy if we encountered them today. Imagine walking along a beach that stretched, unbroken, for thousands of miles. This wasn't like any coastline on Earth today. The shore of Pangea was a single continuous beach that you could theoretically follow from what would become Alaska all the way to what is now Chile, never once encountering a river mouth or peninsula to break your journey. The ocean itself was unlike anything we know. Pangea, the universal sea, contained more water than all of Earth's current oceans combined. It covered nearly 3/4 of the planet's surface, a blue vastness so enormous that storms could travel across it for months without ever encountering land. But it's at the meeting point between this universal ocean and this supercontinent that the real magic happened. The warm waters, heated by a sun that blazed more intensely than today, supported coral reefs that dwarfed anything we see now. Picture coral formations stretching for hundreds of miles, rising from the ocean floor like underwater mountain ranges, painted in colors that have no names in any human language. These reefs weren't built by the familiar corals we know today. The ancient reef builders were creatures called rugose corals, shaped like horns and cups, some growing to the size of small trees. Among them lived creatures that seemed pulled from mythology. Sea lily that swayed in the current like underwater flowers, their stems reaching heights of 30 feet or more, creating forests beneath the waves. Swimming through these ancient seas were fish unlike any alive today. Some had bodies armored with bone plates that made them look like swimming tanks. Others had developed razor-sharp teeth arranged in spirals, creating sawing mechanisms that could slice through the toughest shells. The largest of these ancient fish grew to the size of city buses, gentle giants that filtered plankton through gill rakers, the size of dinner plates. But the most extraordinary creatures in these Pangean seas were the ammonites, relatives of today's squid and octopus, but housed in shells that spiraled into mathematical perfections. Some ammonites grew shells wider than you are tall, decorated with ridges and spines that seemed designed by alien artists. These weren't just beautiful. They were sophisticated hunters, equipped with tentacles lined with hooks, eyes as complex as those of modern eagles, and jet propulsion systems that allowed them to shoot through the water like living torpedoes. The warm climate meant that tropical seas extended far beyond what we consider the tropics today. Palm trees grew in Alaska, and coral reefs thrived where London now sits. The boundary between seasons was so gentle that many plants simply never stopped growing, creating forests of impossible lushness. As you continue your journey through this ancient world, let your mind drift along these endless shores, where every tide brought treasures that no human eye has ever seen, where the warm waters held secrets that we're only now beginning to understand. The contrast between the harsh interior and these lush coastlines made Pangea a world of extremes, where the difference between paradise and wasteland could be measured in just a few hundred miles. This connection between the impossible discovery we started with and the alien beauty of these ancient shores reveals something profound about our planet. Earth has always been a world of incredible diversity, but the patterns of that diversity have changed in ways that challenge our deepest assumptions about what's normal, what's possible, and what's permanent in the natural world. In what would one day become Pennsylvania, something impossible was happening. A forest was growing, but this wasn't like any forest that exists on Earth today. The trees reached heights of 100 feet or more, yet they had no leaves. Their trunks were hollow, their branches ended in feathery fronds, and their roots drank from swamps that never saw winter. These were the coal forests of Pangea, and they represent one of the most alien ecosystems our planet has ever supported. Close your eyes and imagine walking through this strange woodland, where the familiar rules of plant life seem suspended in favor of something far more mysterious. The dominant trees weren't really trees at all, but giant versions of plants we now consider tiny and humble. Picture a club moss, the small green plant you might find creeping along a forest floor today. Now imagine that same plant, but 120 feet tall and 6 feet in diameter, its hollow trunk rising like a massive green column into a canopy of delicate, scale-like leaves. These giants, called lepidodendron, or scale trees, grew at an impossible rate. A tree that would take an oak century to match could reach full size in just 15 years. They invested almost nothing in structural strength, creating hollow trunks that were more like living green towers than solid wood. When they died, they fell easily, creating massive logjams that would become the coal beds we mine today. But the scale trees weren't alone in this impossible forest. Growing beside them were equally alien giants, called sigillaria seal trees, whose trunks were marked with diamond patterns that looked like they had been carved by master craftsmen. These trees grew in dense groves, their perfectly straight trunks rising like the columns of some natural cathedral. The understory of these forests was filled with ferns that grew to the size of modern trees, their fronds spreading 20 feet across, creating an emerald canopy at head height. Some of these ferns developed a strange adaptation that allowed them to become trees themselves, growing thick, sturdy trunks that supported enormous crowns of feathery leaves. Perhaps most alien of all were the seed ferns, plants that looked like ferns but reproduced like flowering plants, even though flowers wouldn't be invented by evolution for another 150 million years. These plants developed seeds the size of chicken eggs, protected by hard shells that could survive the periodic droughts that swept across even these lush forests. The air in these coal forests was different from any atmosphere Earth has known before or since. Oxygen levels reached 35%, compared to 21% today. This supercharged atmosphere had profound effects on life. Insects grew to impossible sizes, dragonflies with wingspans wider than hawks, millipedes longer than alligators, and spiders the size of house cats. The abundance of oxygen also meant that fires, when they started, burned with incredible intensity. Lightning strikes would ignite blazes that could consume thousands of square miles of forest in a matter of days. But these forests were adapted to fire in ways that seem impossible. Many plants actually depended on periodic burning to clear the understory and provide fertile ash for new growth. The most extraordinary aspect of these coal forests wasn't visible to any observer walking through them. These plants were performing one of the greatest acts of planetary engineering in Earth's history. They were removing carbon dioxide from the atmosphere at a rate never seen before or since, locking it away in their massive trunks and roots. When these giants died and fell into the acidic, oxygen-poor swamps, they didn't decay as trees do today. Instead, they were gradually compressed and transformed into coal, creating buried treasure troves of ancient sunlight that we're still mining 300 million years later. As you drift deeper into the rhythms of this ancient world, imagine the sounds of this impossible forest, the creaking of hollow trunks swaying in the wind, the rustle of fern fronds the size of umbrellas, the buzz of dragonflies larger than modern birds. This was a world where evolution was still experimenting with the very concept of trees, creating solutions to the problem of growing tall that have never been tried again. These forests, growing where New York and London now stand, were part of what made Pangea not just a different arrangement of land, but a fundamentally different kind of planet. In the warm, humid forests and vast floodplains of Pangea, evolution was conducting its most ambitious experiment yet. For the first time in Earth's history, life was attempting to grow truly enormous on land, creating creatures that would dwarf anything we know today. Picture, if you will, standing in a forest clearing where Berlin now sits, but 280 million years ago. The air is thick and warm, heavy with the scent of unfamiliar vegetation. The ground beneath your feet is soft and spongy, covered with primitive mosses and the fallen fronds of tree-sized ferns. And then you hear it, a sound like distant thunder, rhythmic and growing stronger. Through the alien trees comes walking the largest land animal that had ever existed up to that point. Coryphodon, a reptile the size and weight of a modern rhinoceros, but unlike any creature alive today. Its massive body was supported on legs like tree trunks, and its small head, almost comically tiny for its enormous body, swayed back and forth as it searched for the soft shoots and leaves that made up its diet. But Coryphodon was just one member of a cast of creatures that would seem like fantasy if we encountered them today. Sharing these ancient landscapes were the earliest relatives of mammals, creatures that were experimenting with entirely new ways of being alive. One of the most extraordinary was Estiminosauchus, whose name means crowned crocodile, though it was neither a crocodile nor a crown bearer in any sense we would recognize. This creature, the size of a large bull, sported a bizarre arrangement of horns and ridges on its skull that made it look like something from an alien world. These weren't weapons for fighting, but elaborate display structures, possibly used for species recognition or courtship in ways we can barely imagine. The predators of this world were equally alien. Inostrancevia, a saber-toothed beast the size of a grizzly bear, stalked through the forests with canine teeth longer than railroad spikes. But this wasn't a cat or even a mammal as we understand them today. It was something entirely different, a therapsid, representing evolution's first serious attempt at creating warm-blooded, active predators. But perhaps the most alien creatures of Pangea were the amphibians. Today, we think of amphibians as small, delicate creatures, frogs and salamanders, that rarely grow larger than your hand. In Pangea's warm, wet world, amphibians became giants. Mastonsaurus grew to the length of a small car, with a skull over 4 feet long and jaws that could snap a modern alligator in half. These weren't just enlarged versions of modern amphibians. They were something entirely different, creatures that had never quite decided whether they wanted to live in water or on land. Some retained the ability to breathe through their skin their entire lives, requiring them to stay moist, but allowing them to remain underwater for hours at a time. The herbivores of this world developed the most extraordinary adaptations. Some, like Eutytherium, grew multiple horns arranged in patterns that seemed to follow no earthly logic. Others, like the early relatives of mammals called anomodonts, developed turtle-like beaks capable of shearing through the toughest plant material, but attached to bodies that moved with surprising grace and speed. But it was the sheer abundance of life that would have been most shocking to modern eyes. These weren't sparse populations eking out survival in a harsh world. The warm, humid climate and abundant vegetation of Pangea supported densities of large animals that we can barely imagine. Herds of plant eaters moved across the landscape in numbers that blocked out the horizon, followed by packs of predators unlike anything alive today. The night sounds of Pangea would have been a symphony of calls, roars, and songs that no human ear has ever heard. Creatures communicated across the darkness with vocalizations ranging from subsonic rumbles that traveled for miles to ultrasonic squeaks that modern technology is only beginning to detect in the fossil record. As you settle deeper into the peaceful rhythms of this ancient world, imagine yourself witnessing these great migrations, feeling the ground shake under the footsteps of creatures that were as real as any animal alive today, but following the rules of an entirely different kind of planet. The giants of Pangea weren't just larger versions of modern animals. They were evolution's first attempts at solving problems that would be solved very differently by the time humans appeared on Earth. They represent pathways not taken, possibilities explored, and then abandoned when the world changed in ways that made their solutions obsolete. But the story of Pangea was far from over. The very forces that had brought the supercontinent together were about to tear it apart in ways that would change everything. As we move deeper into our journey through Pangea, the tone of our story must shift, for we are approaching one of the most profound and mysterious events in Earth's history. The great supercontinent, with all its impossible forests and giant creatures, was about to face a catastrophe so complete, so devastating, that it would eliminate 96% of all marine species and 70% of all terrestrial life. This event, which scientists call the Permian-Triassic extinction, or sometimes simply the Great Dying, marks the end of the Paleozoic era and the ancient world of early Pangea. It was the closest life on Earth has ever come to complete extinction, and its causes remain one of the greatest mysteries in paleontology. But let us approach this cosmic catastrophe gently, like a meditation on the impermanence of all things. For understanding extinction events can actually be deeply peaceful. They remind us that change, even dramatic change, is the most fundamental aspect of existence, and that from every ending comes a new beginning. Picture the world of Pangea about 252 million years ago. The great coal forests were beginning to decline as the climate grew warmer and drier. The massive amphibians and early synapsids we've encountered were thriving in their alien ecosystems. The seas were full of creatures unlike anything alive today, the last of the trilobites, sea creatures that had survived for nearly 300 million years, and massive rugose corals that built reefs in tropical seas where Siberia now lies. Then, over a period of perhaps 60,000 years, an almost impossibly short time in geological terms, something began to go terribly wrong. In what is now Siberia, massive volcanic eruptions began that would continue for almost 1 million years. But these weren't ordinary eruptions. The Siberian traps, as geologists now call them, represented the largest volcanic event in Earth's recorded history. Imagine a volcanic eruption that covers an area the size of Alaska and Washington, combined with lava hundreds of feet thick. Then imagine this happening not once, but repeatedly for almost 1 million years. The amount of lava erupted was so enormous that if it were spread evenly across the entire surface of the Earth, it would form a layer 10 feet thick. But the lava itself wasn't what caused the extinction. It was what came with it. Massive amounts of carbon dioxide, sulfur dioxide, and toxic metals poured into the atmosphere. The chemistry of the oceans changed so dramatically that they became acidic and lost most of their oxygen. The atmosphere warmed so rapidly that the polar ice caps melted completely, and average global temperatures rose by as much as 18 degrees Fahrenheit. But perhaps most devastating of all was the release of hydrogen sulfide gas from bacteria in the oxygen-depleted oceans. This toxic gas, which smells like rotten eggs and is lethal in small concentrations, may have reached levels in the atmosphere that made simply breathing impossible for most land animals. The extinction didn't happen all at once. Instead, it unfolded like a slow-motion catastrophe over tens of thousands of years. Forests died and were not replaced. Coral reefs dissolved in the acidifying oceans. Animal species vanished one by one until entire ecosystems collapsed. Yet even in the midst of this planetary catastrophe, life demonstrated its most remarkable quality, its absolute refusal to give up. Some creatures found ways to survive in refuges we can barely imagine. Deep caves became arks for species that could tolerate darkness and limited food. High mountain valleys, isolated from the worst of the atmospheric changes, sheltered small populations of plants and animals. The survivors of the Great Dying were not necessarily the largest, strongest, or most numerous creatures of their time. They were the most adaptable, the most creative, the most willing to change everything about how they lived in order to keep living at all. As we drift through this meditation on extinction and survival, let yourself feel the profound peace It comes from understanding deep time. The catastrophe that ended the Paleozoic world was complete, but it was not final. Life persisted, evolved, and eventually flourished in ways that were more diverse and beautiful than ever before. The story of Pangea was entering its final chapters, but those chapters would witness transformations more dramatic than anything we've encountered so far. From the ashes of the great dying, a new world was about to be born, stranger and more wonderful than the one that had been lost. As we enter the gentler phase of our journey through Pangea, let your breathing slow and deepen. We are moving now into the Triassic period, a time of recovery and renewal, when life was slowly, patiently, rebuilding itself after the great dying. This is a story of resilience, of the quiet persistence of life in the face of seemingly impossible odds. The early Triassic world was a sparse, simplified place. The great coal forests were gone, replaced by landscapes dominated by a few hardy species of plants. The massive coral reefs had dissolved away, leaving behind empty seas slowly repopulating with simple organisms. It was as if the Earth had been returned to an earlier, more primitive state, forced to begin the long process of evolution all over again. But in this apparent devastation, something beautiful was happening. The survivors of the great dying were not just clinging to existence. They were innovating, exploring new possibilities, discovering ways of being alive that had never been tried before. In the warm, humid environments near Pangea's coasts, small reptiles were beginning to experiment with a revolutionary new approach to reproduction. Instead of laying their eggs in water like amphibians, or burying them in soil like most reptiles, these creatures were learning to retain their eggs inside their bodies, nourishing their young until they were ready to face the world. This innovation would eventually lead to the evolution of live birth, but in the Triassic, it was still a crude experiment. Some species laid eggs with shells, so thin they were almost like membranes. Others produced eggs that hatched almost immediately, creating what appeared to be live birth, but was actually just extremely shortened incubation. At the same time, in the recovering forests, plants were rediscovering the art of growing tall. The new trees weren't like the hollow giants of the coal swamps. These were solid, woody plants that invested heavily in structural support. They grew more slowly than their Permian predecessors, but they were built to last. The most successful of these early Triassic trees were conifers, plants that reproduced using cones instead of the elaborate sporing systems of earlier forests. These trees seemed to understand something about surviving in an uncertain world. It was better to grow slowly and steadily than to reach great heights quickly and risk collapse. The oceans, too, were slowly healing. In the clear, warm waters near Pangea's shores, new kinds of coral were experimenting with different approaches to reef building. These weren't the massive, horn-shaped rugose corals of the Paleozoic, but smaller, more delicate creatures that built their skeletons in intricate, branching patterns. Swimming among these recovering reefs were the earliest true fish, as we would recognize them today. These weren't the heavily armored creatures of earlier periods, but sleek, efficient predators with flexible backbones, sophisticated sensory systems, and the ability to move through water with a grace that their predecessors had never achieved. But perhaps the most significant development of the early Triassic was happening on land, in the form of small, agile reptiles that were learning to walk in an entirely new way. Instead of sprawling like lizards, with their legs spread wide to the sides, these creatures were drawing their legs underneath their bodies, creating a more efficient, energy-saving gait. This change in posture was more revolutionary than it might appear. By supporting their weight more efficiently, these reptiles could be active for longer periods, could grow larger without becoming clumsy, and could develop more sophisticated behaviors. They were laying the groundwork for one of the most successful groups of animals in Earth's history. As we rest in the gentle rhythms of this recovering world, imagine the soft sounds of this healing landscape, the whisper of wind through newly evolved conifer needles, The gentle splash of primitive fish in clear, warm lagoons. The quiet footsteps of small reptiles exploring their slowly expanding world. The Triassic world was not as spectacular as the Paleozoic worlds that came before it, but it possessed a different kind of beauty. It was the beauty of persistence, of life's patient determination to not just survive, but to thrive, to grow, and to explore new possibilities, even after the most devastating setback in its history. This quiet resilience of the Triassic sets the stage for what would become the most famous chapter in Pangea's story, the rise of a group of animals that would dominate the planet for the next 165 million years. The age of the dinosaurs was about to begin. In the warm, humid forests of Middle Triassic Pangea, something extraordinary was stirring. Small reptiles, no larger than modern house cats, were beginning to experiment with a way of moving that would eventually conquer the world. They were learning to stand upright, to balance their bodies over their hind legs, and to move with a speed and agility that no land animal had ever achieved before. Let your mind drift gently into this ancient world, where the familiar map of Earth was still unrecognizable, but where creatures were evolving that would have seemed mythical to earlier periods. These were the first dinosaurs, though they bore little resemblance to the giants that would later capture our imaginations. Picture Eoraptor, one of the earliest dinosaurs, standing barely 3 feet long from nose to tail. Its body was slender and graceful, built for quick movements through the undergrowth of fern prairies and early conifer forests. Unlike the sprawling reptiles that dominated the world around it, Eoraptor could rear up on its hind legs and run with a fluid, bird-like gait that would have seemed impossible to creatures adapted to crawling or waddling. These early dinosaurs weren't the apex predators of their world. That role still belonged to the archosaurs, massive crocodile-like creatures that ruled the rivers and swamps. The dinosaurs were small, opportunistic creatures, content to catch insects, small reptiles, and early mammals in the spaces between the territories of larger predators. But they possessed something that would prove more valuable than size or strength: efficiency. Their upright posture allowed them to cover great distances with minimal energy expenditure. Their hollow bones, inherited from their archosaur ancestors, made them light without sacrificing strength. Their relatively large brains, compared to other reptiles of their time, allowed them to develop more complex behaviors and respond more quickly to changing environments. In the gentle warmth of Triassic nights, as you drift deeper into peaceful sleep, imagine these first dragons moving through moonlit forests that existed where New York now stands. Their soft footsteps barely disturbed the primitive mosses and ferns that carpeted the forest floor. Their large eyes, adapted for hunting in the dim light beneath the forest canopy, reflected the moonlight like jewels. The world these early dinosaurs inhabited was still recognizably part of Pangea, but the supercontinent was beginning to show signs of the stress that would eventually tear it apart. Vast rift valleys were opening across what would become the Atlantic Ocean. Volcanic activity was increasing along these rifts, occasionally painting spectacular sunsets across skies that no human eyes would ever see. The climate was warmer and more humid than today, with no polar ice caps and sea levels much higher than our modern world knows. Palm trees grew in Alaska, and coral reefs thrived in seas that covered much of what is now Europe. The seasonal differences that define our modern world were muted. Instead of sharp transitions between winter and summer, the Triassic world experienced gentle variations in rainfall and temperature that followed rhythms lost to modern climates. In this greenhouse world, plants were experimenting with new forms of beauty. The first cycads were appearing, plants that looked like a cross between palms and ferns, with thick succulent trunks and crown of feathery fronds. These plants would become so successful that the later Mesozoic era would be known as the Age of Cycads, as much as the Age of Reptiles. Alongside the cycads, early conifers were developing the classic forms we still recognize today. The first pines, spruces, and firs were taking shape, their needle-like leaves perfectly adapted to conserve water even in this humid world. These trees were preparing for climate changes that wouldn't arrive for millions of years, evolving features that would serve them well in drier times to come. But perhaps the most profound change happening in the Triassic world was invisible to any observer of the time. The first flowers were beginning to evolve, though they wouldn't appear for another 100 million years. The genetic machinery that would eventually produce roses, orchids, and cherry blossoms was being assembled in primitive plants that showed no hint of their spectacular future. As we rest in this ancient world of gentle warmth and endless summers, feel the deep peace that comes from understanding our place in deep time. These first dinosaurs, stepping lightly through forests that would be gone long before humans appeared, were as real as any animal alive today. They breathed the same elements we breathe, felt hunger and satisfaction, fear and contentment, the basic experiences that connect all living things across vast spans of time. The age of small dinosaurs was drawing to a close. The stage was being set for one of the most dramatic transformations in Earth's history. As Pangea prepared to break apart and scatter its pieces across a widening ocean, creating the world we know today. As we drift into the most peaceful phase of our journey, let your consciousness float gently backward to about 200 million years ago, when Pangea began its slow, inevitable dissolution. This wasn't a violent shattering, but rather the gentlest possible separation, like a flower opening its petals to the sun, unfolding over tens of millions of years. The forces that would break apart the supercontinent had been building deep beneath the surface for eons. Picture the Earth's interior not as solid rock, but as a slowly churning ocean of molten stone, driven by the heat of the planet's formation and the decay of radioactive elements deep in the core. This molten sea creates massive convection currents, rising and falling like the circulation in a pot of heated honey. These currents, moving at speeds measured in inches per year, had been slowly undermining Pangea from below. The continental crust, floating on this sea of liquid rock, began to stretch and thin as the underlying currents pulled in opposite directions. Imagine a piece of taffy being gently pulled apart, thinning in the middle until it finally separates into two pieces. The first signs of the breakup appeared as vast rift valleys, great cracks in the earth that stretched for thousands of miles. These weren't sudden ruptures, but gradual separations that opened over millions of years, creating long, narrow valleys filled with lakes that had no outlet to the sea. In these isolated bodies of water, evolution continued its experiments in isolation, creating creatures that existed nowhere else on Earth. One of the largest of these rift systems opened along what would eventually become the Atlantic Ocean. For millions of years, this was not an ocean at all, but a series of long, narrow lakes and salt flats, slowly widening as North America and Africa drifted apart at the speed your fingernails grow. The volcanic activity that accompanied this rifting was unlike anything the world had ever seen. Massive lava flows, covering areas the size of modern countries, poured out along the rift zones. These weren't explosive eruptions, but gentle effusions of molten rock that flowed like rivers of fire across the landscape, eventually cooling to form the bedrock that underlies much of the eastern United States and western Africa. But the most profound changes weren't geological. They were climatic. As Pangea began to separate, ocean currents that had been blocked for hundreds of millions of years suddenly found new pathways. The single vast Panthalassa Ocean began to divide into smaller seas, each with its own patterns of temperature and circulation. The climate began to moderate as the vast continental interior of Pangea shrank, and more land came within the moderating influence of the oceans. The extreme seasonal swings that had characterized the supercontinent's heartland gradually gave way to more gentle variations. Rain began to fall in regions that had been desert for millions of years. These changing conditions created opportunities for life that hadn't existed since before Pangea formed. Plants began to recolonize the continental interiors, followed by animals that had been confined to the coastal regions for geological ages. It was like watching a great rewilding project unfold over tens of millions of years. The dinosaurs, still small and relatively insignificant, found themselves in a world with rapidly expanding habitats and new ecological opportunities. Some began to specialize in the expanding forests, developing longer necks to browse on tall plants. Others adapted to the new grasslands that were beginning to appear, becoming swift runners with powerful legs designed for open country travel. In the warming oceans, marine life was undergoing its own renaissance. The simple communities that had survived the Great Dying were giving way to increasingly complex ecosystems. New types of coral were building reefs that rivaled anything from the Paleozoic era, and fish were evolving into forms that would be recognizable to modern eyes. But perhaps the most beautiful aspect of Pangea's breakup was the way it created new opportunities for evolution to explore. As the continents separated into smaller landmasses, populations of plants and animals that had been part of single widespread species became isolated. Over millions of years, these isolated populations evolved in different directions, creating the diversity of life that would characterize the rest of Earth's history. As you rest in the gentle rhythms of this cosmic transformation, imagine yourself floating high above the slowly separating continents, watching the birth of the Atlantic Ocean as it grew from a narrow lake to a vast sea. Feel the peace that comes from understanding that even the most dramatic changes in Earth's history unfold with infinite patience, like a meditation spanning geological ages. The world that emerged from Pangea's breakup would be fundamentally different from the supercontinent that had dominated the planet for over 100 million years. It would be a world of moderate climates, diverse habitats, and unprecedented opportunities for life to flourish in ways that had never been possible before. The stage was now set for the most spectacular chapter in Earth's history, the rise of the giants that would make the Mesozoic era the most famous period in the planet's past. Let your breathing become slow and rhythmic as we enter the most peaceful phase of our journey, drifting into the warm, gentle world of the Jurassic period, when Pangea's fragments had begun to separate, but were still close enough to share their climates and their life. This was the Earth of 150 million years ago, a planet so different from our own that it might as well have been an alien world, yet so beautiful that it seems like something from a perfect dream. The climate was warm and humid everywhere, with no ice caps at the poles and sea levels so high that much of what we now call dry land lay beneath shallow tropical seas. Picture yourself walking through a forest where Colorado now stands, but in this ancient time, the air is thick and warm, carrying the scent of unfamiliar flowers and the rich, loamy smell of decomposing vegetation. Ferns as tall as modern trees create a canopy overhead, their fronds filtering the sunlight into patterns of gold and green that dance across the forest floor. Moving through this ancient garden with footsteps so gentle they barely disturb the soft carpet of fallen leaves are creatures that would dwarf anything alive today. Brontosaurus, despite its familiar name, moves with surprising grace for an animal the length of 3 school buses. Its long neck sways rhythmically from side to side as it searches for the choicest leaves, its movements as fluid as a swan gliding across still water. The sounds of this Jurassic world would be unlike anything modern ears have heard. The deep, resonant calls of sauropods, rumbling through the forest like distant thunder, harmonizing with the higher-pitched songs of smaller dinosaurs and the gentle rustle of giant ferns swaying in warm breezes. There were no bird songs yet, for true birds were still evolving, but there were other voices, the chirping of early mammals, the buzzing of insects, and the soft splash of primitive crocodiles in lazy rivers. In clearings where sunlight reached the ground, herds of Stegosaurus moved slowly through beds of cycads and early flowering plants. These gentle giants, with their distinctive plates and spikes, were living solar collectors, turning their broad, flat plates toward the sun to warm their massive bodies, then rotating away from the heat when they grew too warm. The predators of this world were equally magnificent. Allosaurus, with its powerful legs and razor-sharp teeth, stalked through the shadows between the giant ferns. But even these formidable hunters moved with a kind of grace, their attacks swift and precise rather than brutal. In this abundant world, there was enough for everyone, and violence was more performance than necessity. The oceans of the Jurassic were perhaps even more spectacular than the land. In the warm, shallow seas that covered much of Europe, marine reptiles grew to sizes that challenge imagination. Leadsichthys, a fish the size of a modern blue whale, filtered plankton through massive gill rakers as it cruised slowly through tropical seas. Swimming alongside, it were plesiosaurs with necks longer than telephone poles and flippers that could propel their massive bodies through the water with the grace of sea turtles. But it was the smaller details of this world that would have been most enchanting. Dragonflies with wingspans wider than dinner plates patrolled the airways above still ponds. Ammonites with shells decorated in patterns of mathematical perfection jetted through coral reefs built by creatures that glowed with bioluminescent beauty. Early birds, still more reptile than fowl, glided between trees on wings that caught the light like stained glass. The plants of this world were experimenting with beauty in ways that seem almost artistic. The first flowers were beginning to appear, small and simple by modern standards, but revolutionary for their time. These early blossoms attracted the first pollinating insects, beginning a partnership between plants and animals that would eventually paint the world in colors, more brilliant than any that had existed before. As night falls on this ancient world, let your consciousness drift with the gentle movements of long-necked giants browsing peacefully in moonlit clearings. Feel the warm, humid air on your skin. Breathe in the rich sense of an alien, but somehow familiar paradise. This was our planet once, as real as the world outside your window, but following rules of beauty and abundance that we can barely imagine. The Jurassic world represents life's greatest experiment with size and abundance. It was a time when the Earth's ecosystems were so productive, so efficient at capturing and using energy, that they could support animals of incredible size in numbers that seem impossible. It was as if the planet itself had become a vast garden, tended by forces we're only beginning to understand. This garden of giants would persist for millions of years, but like all things in Earth's history, it was temporary. The forces that would eventually transform this world into something more familiar were already at work, preparing for the next great chapter in our planet's story. As you settle deeper into the peaceful rhythm of deep time, let your mind drift into the later Mesozoic world, where a quiet but profound revolution was transforming life on Earth in ways that would echo through all the ages to come. This wasn't the dramatic spectacle of giant reptiles or massive volcanic eruptions, but something far more subtle and ultimately more significant: the invention of flowers. In the warm, humid forests of what would become North America and Asia, small, unremarkable plants were conducting experiments that would change the world. The first flowers were tiny, simple things, barely noticeable, among the giant ferns and towering conifers that dominated the landscape. They had just a few petals, often green or yellow, and they bloomed for only a few days before fading away. But these humble beginnings contained the seeds of a transformation that would make the modern world possible. For the first time in Earth's history, plants and animals were entering into partnerships of mutual benefit that would grow more complex and beautiful with each passing million years. Picture a small moth-like insect, no bigger than your thumbnail, landing on one of these primitive flowers. As it searches for the protein-rich pollen that will feed its larvae, it unknowingly picks up tiny grains on its fuzzy body. When it flies to the next flower, it carries with it the genetic material that will allow plants to reproduce across distances that would have been impossible before. This partnership between flowering plants and their pollinators started a cascade of changes that would reshape entire ecosystems. Plants could now invest less energy in producing massive amounts of pollen to be scattered by wind. and more energy in creating attractive flowers and nutritious rewards for their animal partners. The results were spectacular. Over millions of years, flowers became larger, more colorful, and more intricately shaped. Some evolved to attract specific pollinators, creating relationships so intimate that neither partner could survive without the other. Orchids developed elaborate mechanisms that forced visiting insects to follow precise paths that ensure perfect pollen placement. Other flowers created landing platforms for their visitors, or developed scents that could be detected from miles away. But the revolution wasn't limited to flowers. The seeds of flowering plants were enclosed in fruits, packages of nutrition designed to entice animals to carry them far from the parent plant. This led to the evolution of the first truly modern forests, where trees and their animal partners worked together to create ecosystems of incredible productivity and diversity. In these flowering forests, small mammals were beginning to play increasingly important roles. No longer just tiny shrew-like creatures hiding in the shadows of dinosaurs, mammals were diversifying into ecological niches that had never been filled before. Some became specialized seed dispersers, others became pollinators, and still others became the gardeners of the forest, their activities helping to maintain the complex relationships between plants and their partners. The oceans, too, were undergoing quiet transformations. Microscopic marine plants were developing new strategies for capturing sunlight and nutrients, creating the foundation for food webs of unprecedented complexity. The chalk cliffs of Dover and other limestone formations around the world are monuments to this revolution, built from the calcium carbonate shells of countless tiny marine organisms. As you drift through this gentle world of evolutionary innovation, imagine floating through a Cretaceous forest where familiar shapes are beginning to emerge from the alien landscape of earlier periods. The first recognizable oak trees are beginning to appear, along with magnolias, sycamores, and other trees that would not look entirely out of place in a modern forest. The air is filled with new sounds, the hum of bees visiting flowers, the calls of early birds that are beginning to look and sound more like modern species, and the rustling of leaves that are broader and more varied than the needle-like leaves of conifers or the feathery fronds of ferns. But perhaps most significantly, this flowering world was creating the conditions that would allow mammals to flourish after the age of reptiles ended. The diverse, nutritious plant foods produced by flowering plants, from fruits and nuts to nectar and protein-rich seeds, provided the energy sources that would fuel the mammalian radiation that was still millions of years in the future. The revolution of flowers wasn't dramatic or sudden. It unfolded over tens of millions of years, spreading gradually across continents that were still drifting apart as Pangea's fragments continued their slow journey toward the positions they occupy today. But its effects were profound and permanent, creating the foundation for the modern world in ways that we're still discovering. As your breathing slows and deepens in rhythm with these ancient cycles of growth and change, rest in the knowledge that this quiet revolution created much of the beauty we see in the natural world today. Every flower that brightens your day, every fruit that nourishes your body, every tree that provides shade and oxygen, traces its ancestry back to these humble experiments in an ancient world that existed long before humans appeared on Earth. The stage was now set for the final chapter of Pangea's story and the beginning of the world we know today. As our long journey through deep time draws to its peaceful close, let your consciousness float gently into the final moments of Pangea's story and the birth of the world we recognize today. The great supercontinent that had dominated Earth for over 100 million years was now completely dissolved, its pieces scattered across a globe that was beginning to look remarkably familiar. The Atlantic Ocean, which had begun as a narrow rift valley between North America and Africa, had grown into a vast sea that looked much like the Atlantic we know today. Europe and Asia had collided to create the early versions of the Alps and Himalayas. India was racing northward on a collision course with Asia that would eventually raise the highest mountains on Earth. Australia was drifting toward its modern position in the southern hemisphere. But this wasn't yet the Earth we know. The climate was still much warmer than today, with palm trees growing near the poles and no permanent ice anywhere on the planet. Sea levels were hundreds of feet higher than our modern oceans, creating vast shallow seas that covered much of what we now call dry land. In these warm, humid conditions, life was reaching levels of diversity and complexity that the world had never seen before. The flowering plants that had begun their quiet revolution in the previous chapter were now painting the world in colors more brilliant than any that had existed in Earth's earlier history. Roses, lily, and sunflowers brightened landscapes where giant reptiles still roamed, but where mammals were growing larger and more diverse with each passing million years. The dinosaurs themselves were reaching their own pinnacle of diversity and specialization. Tyrannosaurus rex stalked through forests of flowering trees, while herds of duck-billed hadrosaurs created the first truly musical dinosaur songs, their elaborate crests functioning as resonating chambers that could produce haunting melodies that carried for miles across the landscape. In the skies above, the first truly modern birds were learning to fly with a grace and efficiency that their reptilian ancestors could never have achieved. Alongside them flew pterosaurs of incredible size, some with wingspans wider than small aircraft, soaring on thermal currents above oceans teeming with life. The oceans themselves were undergoing the final stages of their transformation into the seas we know today. The last of the great marine reptiles, creatures like the massive mosasaurs and long-necked plesiosaurs, were sharing the waters with the first whales and the ancestors of modern sharks, dolphins, and sea turtles. But as beautiful and diverse as this late Cretaceous world was, it was living on borrowed time. The same cosmic forces that had shaped Earth's history for billions of years were preparing to write another chapter of change, one that would end the age of reptiles and begin the age of mammals that continues to this day. Yet even as that chapter ended, the legacy of Pangea lived on. The continents that had been joined in that ancient supercontinent still carry the marks of their shared history. The same types of rocks, the same fossil organisms, the same mountain-building events can be traced across oceans and continents, testament to the reality of that ancient world. The coal we burn today was formed in the vast swamps of Pangea. The oil that powers our civilization was created from the marine organisms that lived in Pangea's ancient seas. The very ground we walk on, the mountains we climb, the valleys we call home, all bear the imprint of forces that shaped the supercontinent hundreds of millions of years ago. As you rest in the gentle rhythms of this ancient world, feel the profound peace that comes from understanding your place in the vast sweep of Earth's history. The same elements that formed the rocks of Pangea flow in your blood. The same energy that powered the great forests of the Carboniferous period flows through your body. You are not separate from this ancient world. You are its continuation, its newest chapter, its latest experiment in the art of being alive. The story of Pangea reminds us that change, even dramatic change, is the most fundamental aspect of existence. Continents drift, climates shift, species evolve and extinct, but through it all, life persists, adapts, and finds new ways to flourish. The supercontinent that seemed so permanent, so solid, so eternal, was really just a temporary arrangement, a brief chapter in Earth's ongoing story. But what a chapter it was! In the time of Pangea, life learned to live on land, to grow tall, to fly, to think, and to dream. The foundations were laid for everything that would follow: the rise of mammals, the evolution of intelligence, the development of consciousness, and eventually, the emergence of beings capable of looking back across vast spans of time and understanding their place in the cosmic story. As you drift into peaceful sleep, carry with you the wonder of that ancient world, the knowledge that our planet has always been a place of incredible beauty and diversity, and the understanding that the story of Earth and your place in it is far from over. The next chapters are being written even now by the choices we make, the dreams we dream, and the love we show for this extraordinary planet we call home. Sweet dreams, fellow traveler through deep time. Rest well in the knowledge that you are part of a story more ancient and beautiful than any tale ever told, and that tomorrow brings new opportunities to add your own chapter to Earth's continuing adventure. Thank you for joining me on this journey through the lost world of Pangea. If this cosmic adventure helped you find peace and wonder tonight, please subscribe for more explorations through deep time, and let me know in the comments how this ancient world has changed your perspective on our modern Earth. Until next time, sleep peacefully under the same stars that shone down on Pangea, and dream of the wonders that time and change will bring to our world in the ages yet to come.